Hey guys, welcome to Math for Kids by Kid. In today's video, we are going to talk about integral exponents. Integral exponents are whole number exponents. They can be positive or negative. So examples of this: 9 to the power of 3, 9 to the power of 2, 10 to the power of 5, 8 to the power of negative 3, 7 to the power of negative 6. For all powers with positive exponents, we know how to solve them. For instance, 9 to the power of 3. It means we are multiplying 9 3 times, so 9 times 9 times 9. And from here, we would solve. So this equals 81 times 9, and from here we get 729 as our final answer. But when we have a negative exponent, we can't just multiply the number a negative amount of times, right? So we need to find a way to write the power with a positive exponent. Let's say we have to solve 2 to the power of negative 3. Let's imagine this as a fraction. So 2 to the power of negative 3 over 1. It's the same thing as just 2 to the power of negative 3. Here, we are going to move 2 to the power of negative 3 to the denominator, so it becomes 1 over 2 to the power of 3. In the numerator, we'd put a 1. And this is how you write it with a positive exponent, 1 over 2 to the power of 3. And from here, we would solve, so 1 over 2 times 2 times 2, which is equal to 1 over 8. And this is our final answer. I'll show you another way of thinking of this. So 3 to the power of 2 divided by 3 to the power of 5. And we would subtract the exponents. 2 minus 5 is negative 3, so the answer is 3 to the power of negative 3. And from here, it would be 1 over 3 to the power of 3. So instead of writing this out as having a negative exponent and then moving it to the denominator of the fraction, you can simply write it out as repeated multiplication. So 3 times 3 over 3 times 3 times 3 times 3 times 3. And from here, we can cancel out some numbers. So you can cross out both 3's on the top and 2 3's on the bottom. And you're left with 3 3's in the denominator. And so from here, you get 1 over 3 to the power of 3. And from here, you can solve 1 over 3 times 3 times 3, which equals 1 over 27. So in the example I showed you above, we looked at powers with negative exponents on the numerator and then moving it to the denominator. And this idea of moving a power with a negative exponent to the opposite side of the fraction applies if the power starts in the denominator. So let's say you have 1 over 2 to the power of negative 3, and you have to write this as a positive exponent. We would simply just move 2 to the power of negative 3 to the numerator, so it becomes 2 to the power of 3 over 1, which is just the same as 2 to the power of 3. And from here we would solve 2 times 2 times 2, which equals 8. All the stuff I talked about above of moving the power with a negative exponent to the opposite side of the fraction, that is part of the negative exponent law. It states that a base raised to a negative exponent has the following properties. So in this case, I'm just going to use variables. So a to the power of negative n. This is equal to 1 over a to the power of n, and a is not equal to 0, so the base cannot be 0. And 1 over a to the power of negative n equals a to the power of n, and again, a is not 0. Now we're going to talk about simplifying a fractional base with a negative exponent. So let's say we have 2 over 3 to the power of negative 4. This is really 2 to the power of negative 4 over 3 to the power of negative 4. And because both of these powers have negative exponents, we have to move them to opposite sides of the fraction. So 3 to the power of negative 4 goes on the top, and 2 to the power of negative 4 goes on the bottom. So it becomes 3 to the power of 4 over 2 to the power of 4. And this is really just 3 over 2 to the power of 4. So we can make a rule for this. So we'll use variables here. So a over b to the power of negative n equals b over a to the power of n. And neither a nor b is 0. So in the example I showed you above, 2 over 3 to the power of negative 4 equals 3 over 2 to the power of 4. Now let's solve a few problems. So let's say we have negative 7 to the power of 2 times 8 to the power of negative 2. So we have negative 7 to the power of 2 multiplied by 1 over 8 to the power of 2, because you have to remember that this negative 2 here is negative exponent. And so it needs to go in the denominator of the fraction. And from here, we can see that the negative 7 to the power of 2 multiplies the numerator 1. So we can write it as negative 7 to the power of 2 over 8 to the power of 2. And from here, we can solve. Negative 7 times 7 over 8 times 8. From here, we get negative 49 over 64. This is the final answer. 6 times x to the power of negative 3. So like I said before, any base with a negative exponent has to move to the denominator of the fraction. So in this case, the x is the base with the negative exponent. The 6 is not part of it. That's just a coefficient, but we're not going to move the 6 because it's not part of the base. We're just moving the x. So the 6 stays on top, but the x gets moved to the bottom. So 6 over x to the power of 3. Five times b to the power of 8 times b to the power of negative 12. Multiply that by negative 10 times b to the power of 3 times b to the power of negative 12. So let's deal with each of these brackets first and simplify them before proceeding. So let's deal with this first bracket. The 5 will stay where it is, and then it'll be b to the power of negative 4, because we're multiplying here, so we're adding the exponents. 8 plus negative 12 equals negative 4. Then the second bracket, we have negative 10 times b to the power of negative 9. And now we can proceed from here. So we multiply the coefficients, and we get negative 50. And then we add these exponents, and we get b to the power of negative 13. And we'll put a 1 in the denominator. And we're going to move the b to the power of negative 13 to the bottom. So you get negative 50 over b to the power of 13 as the final answer. (16 times a to the power of 6 times b to the power of negative 3 over negative 4 times a to the power of 6 times b to the power of 3. So first, let's move this b to the power of negative 3 over to the bottom to make it positive exponent. So we get 16 times a to the power of 6 over negative 4 times a to the power of 6 times b to the power of 3 times b to the power of 3. And from here, we can add these exponents. So we get 16 times a to the power of 6 over negative 4 times a to the power of 6 times b to the power of 6. And from here, we can subtract the exponents on both of these a's, and we can divide 16 by negative 4 to get negative 4. So negative 4 over b6. 6 minus 6 is 0, so a to the power of 0 equals 1. So we don't need to write any a there. We're just left with negative 4 over b to the power of 6. This is the final answer. Thanks for watching, guys. I'll see you soon.